Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to teach you how to find the ending directions of a polynomial function from just an equation. So let's start. Our equation is y equals negative x squared times x minus 3 times x minus 2 cubed. So first, what do we know? Well, we know our x-intercepts, and we're going to graph this. So our x-intercepts are 0, because when x equals 0, x squared will be 0, and the equation will be 0. X minus 3, so 3 is one of our x-intercepts. And then x minus 2, so 2 is one of our intercepts. And here we can say, well, 0, of course, is x squared. So this is a squared, which is like a little bounce. We know there's going to be a bounce off of that. And then here, this 2 is cubed, which a cubed means it flattens out when it hits the intercept. So we are going to say on the 2, just make sure that it flattens. It flattens out when it gets to that 2, and then it keeps going. So we know there's a bounce. This one is just a linear. It just goes straight through 3, and then on 2, it'll flatten out and then go through. So we already have some valuable information, but that doesn't really help us with the ends too much. What we're going to do is we're going to make a number line. I know, very exciting. So we're going to put our 0 in the middle, then just 1, 2, 3, and just say like 1, 2, 3. Whatever. Just 2 and 3. So we have 0, 2, and 3. What I like to do is I like to put a big point there to show that those are our intercepts. Now, what we're going to do is we're going to get a point to the left of 0, in between 0 and 2, in between 2 and 3, and to the right of 3. You're going to get points to the far extremes, and then you're going to get points in between every point. So from 0, behind 0, I'm just going to say negative 1. Between 0 and 2, I'm just going to say 1. Then between 2 and 3, I'm going to say 2.5. Now, the fun part about this is you don't actually have to plug the points in. It's great. All you're going to do is see what the sign is. So you're only plugging in these middle points, because you know if you plug in 0, 2, or 3, you're going to get 0 out, and that's not going to help you. So we plug in negative 1. Well, negative 1. What we're going to do is just plug it in. You could do it on a piece of paper and just say, okay, well, this is going to be negative, this is going to be positive, but we could do it on our head right now. Negative of negative 1 squared. Well, that's negative of 1, so that is a negative. Now, what's next? Negative 1 minus 3. Well, that is negative 4, so it is a negative. Again, all we care about is the sign. Don't care about the number. Now, if it's a negative minus 2, so it'll be like a negative 3 cubed. A negative cubed is still a negative. So it's a negative times a negative times a negative, which these two negatives make a positive, and then a positive times a negative equals a negative. So at negative 1 is a negative. Now, what does that mean? Well, past 0 to the left is going to be going down. So our far ending direction over here is going to be going down. But let's do the whole thing. So now we're going to plug in 1. We plug in 1. Negative of 1 squared is negative 1, so we're going to plug in a negative there. Then 1 minus 3, well, that is negative. Then 1 minus 2 cubed, well, again, that is going to be a negative. And again, right here, we just did negative times negative times negative, which we got a negative again. And that makes sense, right? We're down over here, but then our 0 is a bounce. So we're down, we hit 0, and we bounce off and go down again. So it's all coming together. You can check by seeing your bounces or your flattens or whatever. Now, we plug in 2.5. And I forgot to say we should plug in 1 after 3, so I'm just going to plug in 4. So 2.5. 2.5 squared times a negative. Well, that is, of course, going to be a negative. Now, 2.5 minus 3, well, that is a negative again. Then 2.5 minus 2 is 0.5 cubed, so that is a positive cubed, which again is a positive. So these negatives right here make a positive. So this is a positive times a positive, which is equal to a positive. So that means we're going through 2. We're going just through 2, but remember, it'll flatten out while we go through it. Now, our last point is 4. Let's plug it in. Well, negative 4 squared is, of course, a negative again. Then, there is 4 minus 3. Well, 4 minus 3 is a positive number. Then there is 4 minus 2 cubed, which is going to be a positive number again. And then if we look, positive times positive is positive. Positive times negative is a negative. So we end off with a negative here as well. Now, to graph it, we graph our x-intercepts. Graph 0, graph 2, and graph 3. So we see our first point is negative. So we're going to be going negative. Remember, we said there's a bounce off 0 and it goes negative again. So we're bouncing off 0, going negative, go down an arbitrary amount. Over here, you can just put an arrow or something. It's just a sketch, so you don't have to be too specific with points. Now, we are going positive after 2. So this just means we're going through 2. But remember, the 2 is cubed, so we are flattening out as we go through it. So we're going to just turn arbitrarily down here, and then we're going to like flatten out and kind of just hug that line a little bit. Hug that x-axis for a little bit, and then we're going to go up. And then after this 3, we're going negative, and that is just a normal 3. So we are just going random turn here and down. So this is our final solution. We start negative, and then we're negative again. Then we're positive, then we're negative. And as you see, this is x squared times x is x cubed. Then x cubed times over here will be an x cubed again, is x to the 6th. So this is an even polynomial function, meaning both ends will be going the same way. You can use that to check. If the degree is even, both ends will be going the same way. If the degree is odd, they're going to be going different ways. If the degree is even and negative, both going down. Degree is even and positive, both going up. Degree is odd and positive, left is going down, right is going up. If degree is odd and negative, well, then the left is going up and the right is going down. That's a quick way to check. You might have to rewatch that again because that's how I check, and it works pretty well. So remember, number line, little table, doesn't matter for numbers. Just put negative, negative, positive, whatever. Just find the sign. That's all that matters, and get your x-intercepts. Well, thank you for watching. I hope this helped you determine where the endings are going to go on a polynomial function from an equation.